we're going to be looking at Kirchoff's laws. There are two laws. The first is called the junction rule. The junction rule states that the current going into a junction must equal the current going out of a junction. The second rule is the loop rule, which says that the sum of the voltages must be zero. And we're going to take a look at this in a specific example in the circuit shown below. So, we're going to be using the loop rule. And so I'm going to draw that loop here, and we're going to be going in that direction. Keep in mind that the shorter side of the battery is negative, the longer side is positive. So, the loop rule says that the sum of the voltages has to equal zero. So as we go through at the power supply where we begin, we have plus 12 volts. The next thing we come to is the internal resistor, lowercase r, which is 0.5 ohms. And because we don't have voltage, we're going to use Ohm's law. We're going to express voltage in terms of the product of current times resistance. So that will be, we're going to do minus 0.5 times the unknown current. There is only one current in here because this is a series circuit. Typically you would say I1, I2, depending on which branch. We don't need to do that here. Minus 65 I1 equals 0. And now all we have to do is solve that equation. So we get 12 volts is equal to 65.5 I1, and we can just go ahead and divide to solve that. And there we have it. So the current that passes through this circuit is 0.183 amps. In this next problem, we're also going to be using the loop rule, which says the sum of the voltages is equal to 0 to determine the current and then also the voltage difference between points A and B. So first we're going to set up the loop rule. And I think the best way to do that is to pick where we're going to start. So let's say point A. And we're going to go around in a counterclockwise direction. So first, the loop rule says that the sum of the voltages must be 0. So starting from point A, we have minus I1, because there's only one current, times capital R, plus 1.5 volts minus I1, so now we're at this resistor, times R. Okay, we go through point B, we're at this resistor, minus I1 times R. Okay, we get to this voltage, so we have to add that in, plus 1.5 volts. And then we get to this resistor, so we do minus I1 times R. And now we're back at point A, so we are done. So that we know that's equal to 0. Now, in this case, all of the resistors are the same. They're all equal to 160. So all R's are equal to 160. We'll keep that in mind here in a minute. Let's go ahead and simplify this equation. So we have 3 volts minus 4 I1R is equal to 0. equals 0. And so 4 times 160 is 640. So we have 3 volts equals 640 I1. And then we're going to have to divide to figure out I1. Now we're going to find the voltage drop between points A and B. So we're going to go from point A to point B, following that purple path only. So from A we come to the resistor, so it's going to be minus I times, they're all 160, so I can put the 160 in, or I could leave it as R, plus 1.5 minus I times 160. And now, so we have minus we already know I1. So what do we get? It adds to 0. So there is no voltage difference between points A and point B. We have another problem here. We'll start at the power supply, then we'll go around. So this is again the loop rule, which says that the sum of the voltages in a loop has to be 0. So we have plus 9 volts minus 9.5 I1 minus 14 I1 minus our internal resistance, which is 2 I1, has to equal 0. And when we divide, we get 0.3529 amps. And that is the current. So now let's take a look at a problem with 2 power supplies. Actually, they're in opposite directions. And we're going to be finding the current as well as the terminal voltage across each battery. So the terminal voltage is equal to the electromotive force. So that would be like your 12 volts, your 18 volts, minus the current that passes through that battery times little r, which is the internal resistance of the battery. So every battery uses up some voltage because of its own internal resistance. So the terminal voltage is going to be slightly different than the electromotive force, the EMF. But first, we're going to take a look at the loop rule. And for the loop rule, we are going to look at sum of the voltages equals 0. We're just going to pick a point and we'll see what happens. So we're going to go around. So we're going to start at that dot and we're going to go around. So the first thing is we come to that terminal. Notice we're not going from negative to positive, we're going from positive to negative, which means we're going against the battery. So instead of writing plus 18, I'm going to write minus 18. We're then going through the resistors, so I'm going to write minus, this is little r, the internal resistance, minus 2 I1. So let's add that in. We're actually subtracted in, so minus 4.8 I1. So now we can simplify and solve. So negative 6 volts is equal to negative 3, negative 7.8. But when I put it on the other side, I have to make it positive. We'll write it out. And now we need to solve negative. We need to flip the direction as drawn. So we drew it counterclockwise. So this is actually clockwise. Okay. And now we have two more things to do. We're just going to simply find our terminal voltage. So let's take a look at that. My terminal voltage, we'll do this top one first. So the terminal voltage between 2 points is EMF minus IR. So for us, our electromotive force is 18 minus 2 times our current, which was 0.769. And when we do that, we get 16.46. Now let's take a look at part C. So that's between kind of these 2 points. If you want, you can actually pretend that there's a battery there that looks like this. That would be your positive end of the battery, right? You could put a battery on each one if it helps you to kind of visualize what we're actually calculating. So remember, our actual current is going this way. So we're going against the battery. So my terminal voltage across those two is equal to negative 12, because we're going against it, and then minus our internal our current, excuse me. So I'll just write I1, but we know it's the 0.769 times the 1 ohm. And so when we plug that in, we get negative 12 minus 0.769. And that's going to give you negative 12.769. So the difference between the two is the 12.769 volts. The negative or the positive could flip depending on which direction you were looking at. So there you have it. We have successfully looked at the loop rule.